According to a recent study, some experts believe that 16% of all freshwater fish in a particular country have such high levels of mercury that they are dangerous to eat. Goes on to say we'll assume that we've sampled 200 fish randomly, and we want to find the approximate probability that the market will have a proportion of fish with dangerously high levels of mercury that is more than 2 standard errors above 0.16. I think we can mostly do this within StatCrunch, so I'm going to open up StatCrunch, and I'm going to use the normal calculator. So I'll go to Stat, Calculator, I'll select Normal, and use this thing. What we want to do is come up with a mean and a standard deviation for this particular distribution. So the mean for this sampling distribution, for this proportion, is going to be equal to this number here. So in place of the mean, I'm going to write it as 0.16, which represents the 16%. Now we also need a standard deviation. Now there's a formula for that where you do p, that's this value, 0.16, times 1 minus p, that's 0.84, and then you divide by the sample size, which is 200, and you take the square root of that number. And that thing is our standard error, or standard deviation. So just to go over that, okay, that was 0.16 times 0.84. We divide by the sample size of 200, and then we take the square root of this value. And this here is the standard error or standard deviation, which, okay, I'm going to round it out to a few decimal places, 0.0259. Maybe I'll go 23. I mean, you go up far enough so you know your answer is going to be accurate. In terms of the actual probability that we are looking for, we want to know when we are more than 2 standard errors above 1.6. The above is indicating them using a greater than or equal to. And I just want to know, well, how far? Like, what number do I put here? It says that we're going to take 2 of these standard errors and add it to 0.16. In my calculator, it's pretty easy to do. I'm going to double this number, double my 2 standard errors, and I'll add 0.16 to it. So I'm going to go times 2, and I'm going to add that to 0.16. This is 2 standard errors above 0.16, and that's the number I'm going to put in here. So again, I'm going to round it out to a few decimal places for accuracy, but I'll go 0.2118459. It's probably good enough. Okay, I'm going to compute. And this is the number that I get. Okay, so we're done with the calculator. I'm going to get that out of the way. We want to round to, it says 3 decimal places. Okay, so that's going to be 0.023. Okay, and that is it for this problem.